So the first thing I want you to remember is, if I draw from the North Pole to the South Pole and back around again, a bunch of great circles, and they all pass through the axis of the Earth. Can you remember? What are these great circles called? They're called...
No, longitude.
These are called Meridians of Longitude. Do you remember that?
The prime meridian that runs through Greenwich. England.
Yeah, so I heard it. These are meridians of longitude, not to be confused with parallels of latitude. Latitudes are, after all, parallel to each other. None of them touch each other. Whereas all the meridians of longitude, they all intersect at the North Pole and at the South Pole. Okay? As we pointed out, one of the meridians is more important than the others. It's the prime meridian. And it's important because it has Greenwich on it, right? So I'm going to... It is spelled Greenwich, but Greenwich. Okay. Now, what I want us to think about is, in the course of 24 hours, the Earth basically does one full revolution. Okay? So Greenwich will start, for example, facing the sun, and then 24 hours later it's moved around and it faces the sun again, and it's the same time in the day. Okay? So if there are 24 hours in a day, and remember, the Earth, and therefore each one of those meridians, rotates through how many degrees over that time?
360.
360 degrees, right? That's not what I usually expect. Hi.
Could I have like about 5 or 6 year 7 textbooks? Please?
Oh yeah, of course you can. I think there are a handful behind you. In fact, I think that's 6. Good one. Is that what you said? Yeah, there you go. There you go. Do you want to ask which teacher you're taking? Which teacher are you taking? Thanks. Sorry, where were we? 360 degree what? Revolution in the course of 24 hours?
Plus, never mind.
So, here's what I want us to recognize, right? If there are 24 hours a day and 360 degrees of rotation over the course of that day, then as you move across these meridians, the time is different by, well, have a think about it, okay? Obviously, we don't draw all the meridians on there because otherwise the thing would just be covered. You wouldn't see, like, you know, countries or cities or anything like that. So we tend to draw them spaced out a little bit like this. There are 24 of them, okay? What angle will there be between each one of those meridians if I've drawn 24 of them? 15 degrees. 360 divided by 24. So each one of these meridians, right, which represents an hour, wrong color. 1 hour of time also is represented by 15 degrees difference in longitude. Okay, so at the moment I've drawn this arrow going from west to east, right? So what's the time difference between them? Have I gone, now be careful with your language here, this is actually quite tricky here. Have I gone forward in time or backwards in time?
Are you going forward?
So if I compare, let's actually put some people here, okay? So I'm going to put person A on this meridian and person B on this meridian, okay? Person A on their clock is further forward in time, okay? Because this is the way the sun actually, this is the way the Earth actually rotates, okay? So let's actually put some times on this, right? If I said that this person was at time 12 noon, then this person to the west is going to be at 11 in the morning. Does that make sense? Mm-hmm. Which therefore means if I've done all of these equidistant to each other, and this is another 15 degrees that way, what time would it be in Greenwich right now? 10 a.m. 10 a.m. Now we'll go back to Greenwich. Now, keep in mind, everyone on the same meridian has the same time with a few exceptions. So that's such an important idea, I'm gonna write it down. Everyone on the same meridian. Everyone on the same meridian has the same time. I think that's his same time. With some exceptions.
Isn't China only one time zone?
Okay, so China is one of the big exceptions. So China, did I put my globe away? I didn't put my globe away. Doesn't matter. Everyone can picture how big China is. China goes across several meridians, right? So I'm just going to close this. Howdy juniors. Now, even though it's across several meridians, it stretches across this way, the Chinese government says, actually, all of China, a single time zone. Okay, the entire thing. And there are also, so let's put this underneath, right? Exceptions, right? All of China is one time zone. There are also some people who are on the same meridian, but they are at different times. Does anyone know where this mainly happens? Queenslanders. Okay, so at the moment, right, the part of the Earth that we're facing has Greenwich on it, right? What's the longitude of Greenwich? It's 0 degrees, right? That's where we measure from, okay? Now, therefore, if we follow this guy, follow B and A all the way east, right, eventually we'll get around to the opposite side of the Earth. If we go 180 degrees east, we're going to be on the opposite side, right? But since we're on the opposite side, we could also have gone the other way, right? We could have gone 180 degrees west, and we'd end up on the same spot at the back. Does that make sense? Okay. Now, 180 east and 180 west are at the same spot. They're at the same spot, and we basically call that the International Dateline. Now, the International Dateline is confusing. I actually need to turn this on. But some of you might get there first if you've got computers there. In fact, can you all, if you haven't already, get your device or whatever out? The International Dateline is weird. And we're going to explore this weirdness for a minute.